Hello there, this is a geometry video. It is chapter 11, section 1, and today we're going to begin our journey in finding the area of different figures, of different polygons and circles in chapter 11. And today specifically we're going to be talking about areas of parallelograms and triangles. The first two sections of this chapter are actually going to be fairly easy because I'm quite certain that most of you already know the formulas for these figures, for parallelograms and triangles. Because if you know the area for a rectangle, which I'm sure most of you know is base times height, it turns out that the area of a parallelogram is exactly the same thing. You could actually take the right triangle and cut it off of this figure, for example, and then transpose it over here, and you would actually have a rectangle. All right, so basically for that reason, we have the area of a parallelogram is equal to the base times the height, which of course a rectangle is also a type of parallelogram. But it's nice to know that it also applies to other types of parallelograms. All right, so that's basically the formula for this part. So we're just going to go right into the examples, and it says find the perimeter and area of parallelogram ABCD. Now, for the perimeter, that's pretty simple. That means that we're going to add up all the sides. So we have 2 lengths and 2 widths when you have a rectangle. But in this case, we're going to have 2 pairs of opposite sides. They're not necessarily lengths and widths, but we know that the side AD is 10 inches, which means that BC is also 10 inches. So 2 times 10. And then we know that DC is 4 inches, which means that AB is also 4 inches. So we're going to add 2 times 4, and we're just going to get 20 plus 8, which is, lo and behold, 28 inches for the perimeter. Not very complicated at all. And then we want to find the area. Well, the area of the parallelogram is base times height, so be careful with that because the base is actually, well, there's actually 2 bases here. It kind of depends on how you look at it. Clearly, you can think of this as the base, which is 4 inches, but then your height would have to be a segment that extends from this point perpendicular to the opposite side, which is not drawn, but would obviously be a lot longer than 5 inches. But in this case, because this is the altitude given, it means that we're actually going to treat AD as the base, or basically BC as the base, which is the same thing as AD. So we're going to say the base is 10, and the height is 5, which would then give us 15 square inches for area in this case. Alrighty? Sorry, not 15, 50. Wow. We want 50 square inches for area there, okay? Which would obviously be a lot different if for some reason you used 4 as the base. You would get 5 times 4, which is 20, which would be way off. So make sure that you're using the right base. All right, so now we're going to let you do this do-it-yourself question, and then we will go on to example 2. In example 2, it says find the area of parallelogram EFGH. Alrighty, so in this case, we have the base is given as 15 millimeters, and the height is marked, but we don't know what it actually is. So we know that as far as my formula is concerned, it's going to be base, and then it's times height, and we don't know what the height is. All right, and then you're probably thinking to yourself, okay, well, maybe you could use 8.5. No, 8.5 is the hypotenuse of this right triangle here, which, by the way, they're telling us is a 45, 45, 90, because this is a 90, that's 45, so this must be a 45, 45, 90. That's important because we're going to use our special right triangle information to be able to do that. Now, if you remember, in a 45, 45, 90, you always have leg, leg, and leg root 2. So I'm going to rewrite it for you again in case you have forgotten. In a 45, 45, 90, you have the 2 legs are the same, so x, x, and the hypotenuse is x root 2. Now, in this case, you might even want to call it h, h, h root 2, because this is a leg, and it's called h, which means this leg would be the same thing, h, and then the hypotenuse is h root 2. So what we have to do is to solve the equation h root 2 equals 8.5. Because we know that the hypotenuse is 8.5. So we're going to replace or equate h root 2, which we know it's supposed to be, based on a 45, 45, 90, and equate it to 8.5. So I'm going to now divide by root 2, and h is actually equal to 8.5 root 2 over 2. Now remember that the reason why I did that is because it's improper to have a square root on the bottom. So I am multiplying top and bottom by root 2, so I will get 8.5 root 2. And then root 2 times root 2 is root 4, which is just 2. This is the exact answer. So now I'm just going to take this h value and plug it right into there. So my area is going to equal 15 times 8.5 root 2 over 2. And then I'm going to plug it into my calculator. And they're allowing me to go ahead and round. So I'm going to go 8.5 divided by 2. And I'm going to times it by 15. And I'm also going to times it by the square root of 2. Alrighty? So it turns out that our area is about 90, it's 90.156. So I'm just going to go ahead and say that it's basically, I'm going to round 90 millimeters or my units squared. There's my area. All right, so remember that sometimes you're going to have to get creative with using some of your old tricks to find the missing links there. So here we have do-it-yourself number 2, and then we're going to go to the area of a triangle, which again, I'm pretty confident that most of you guys know the area of a triangle. But again, you can take part of a parallelogram and take two triangles, and you can basically take two triangles and let me see if I can show you. Like, what if I took another triangle, the same exact triangle, like that. So these two triangles are identical, and if you were to put them together, you'd basically have a parallelogram whose area is base times height. So in this case, what's happening is you only want half of that parallelogram, so you end up with only getting base times height divided by 2. So again, this is just another way of showing you why the formula is the way that it is, but I will delete that excess part there. But basically the idea is that you can take this triangle and kind of flip it, and then you would have a parallelogram that would be two triangles. And if you only want the area of one of those triangles, then you would take the area of the entire parallelogram, which is base times height, and then divide it by 2, which is the exact same thing as 1/2 base times height, either way that you look at it. All right, so that's the area of a triangle. And so here we go with example 3. It says, DeAndre needs enough mulch to cover the triangular garden shown. So this is actually, if you look at your book, the actual garden is this part of this black triangle here. The red here is not actually part of the triangle. But he's trying to cover this triangular garden with enough paving stones to border it. Okay, so he's going to put paving stones and he's going to border it, okay? If one bag of mulch covers 12 square feet and one paving stone provides a 4-inch border, how many bags of mulch and how many stones does he need to buy? So basically what we need to do in this problem is find the perimeter and the area, because the stones are going to border it. So that's going to be this part. And that's actually easy because we know that the perimeter is just to add up all the sides. So in this case, our perimeter is going to be 23 plus 7 plus 15. So 23 plus 7 is going to give us 30, and 30 plus 15 is going to give us 45 feet that we need to border. And since each paving stone, if I can read here, one paving stone provides a 4-inch border. So you divide that by 4, and that'll tell us how many stones we need. So 45 divided by 4 is 11.25. Alrighty? So we're going to need okay, I see my problem. Sorry, I'm checking my answer and it's not right. Here's the problem, is that we have difference in units. So we've got 4 inches, not 4 feet. So it's divided by 4 inches, so to speak. And that can't be. So what we want to do is actually maybe convert the 45. Well, we can convert the inches to feet. So let's go ahead and take 4 inches, and we're going to convert it to feet so that there's 12 inches in 1 foot. So it turns out that you get 1/3 feet. So I'm actually going to take 45 and divide it by 1/3, but dividing by 1/3 is the same thing as timesing by 3. So 45 times 3 is going to be how many stones we need. So 45 times 3 is actually 135. So we will need 135 stones, paving stones. So we've answered the first part of the question, and now we need to answer the second part, which is the area. So we want to find the area of this triangle because we know that the bags of mulch, we have 12 square feet. Now the good thing here is that the bags of mulch have the same units, square feet, and feet is what our triangle is in. So they kindly gave us the height of the triangle, even though it's not on the inside of the triangle. This is the height of the triangle. So we're going to say that the area is equal to 1/2 the base, and so the base of the triangle is going to be the 23. So basically what I want to figure out right now is kind of how to explain this to you, if you will. So, pardon me. Okay. So the height is right here given to us as 9. But when you choose this to be your height, then the base has to be the segment that it's perpendicular to. So that doesn't include this piece. So it's just this piece right here. So it's actually 7. All right. If I was using 23 as the base, then I would have to go perpendicular to the opposite side, which would be the segment right here. Okay. If I was using 15 as the base, then I would have to go perpendicular to the opposite side, which would then be over here, something like this, if that makes sense. So in this case, since this is the base, I have to go perpendicular to the opposite side, which is this guy. So that's why it's kind of outside of the triangle. So anywho, for my area, I'm going to get 1/2 times 7 times 9. And 9 times 7 is 63. And 63 divided by 2 is going to be 31.5. So our area is 31.5 square feet. And we know that 1 bag of mulch covers 12 square feet. So we're going to divide that by 12 square feet. And 31.5 divided by 12 square feet is 2.625. Which basically means you're going to have to round up, and you're going to need to buy 3 bags of mulch to finish this job. Alrighty? So that is how you do that, little guy. So now we'll let you do this do-it-yourself question, and then we will go to our last example. The height of a triangle is 5 centimeters more than its base. The area of the triangle is given as 52 square centimeters. Find the base and height. So now what I've done is they didn't actually give you a diagram, but I've drawn a diagram just like a generic triangle, and I'm going to go ahead and call this the base and this the height. And so it tells me that the height, which is h, is equal to, so it says the height is 5 centimeters more than its base. So the base is b, so it's 5 centimeters more than that, so it's b plus 5. So since I know the area of a triangle is 1/2 base times height, I'm just going to replace the h for height with b plus 5. I also know that the area of this particular triangle is 52 centimeters squared, so I'm going to replace the a with 52 and then solve. So I'm going to get rid of this 1/2 first by timesing both sides by 2. So 52 times 2 is going to be 104. And then I'm going to, that gets rid of the little fraction there. And then b times b is b squared. And b times 5 is 5b. All right, so now we're going to go ahead and you can actually solve this now by any of the quadratic techniques that you have behind you. So I'm going to go ahead and put it in standard form first. B squared plus 5b minus 104 equals 0. So if you're curious to what's happening, I'm moving the 104 to the other side, which makes it negative 104, and then equal to 0. Okay, so I'm going to try to factor this guy. I think he's factorable. So b and b times b is b squared. 104, let's try to see what are some factors of 104. 104 divided by 8 is 13. Will that work? I think so. 104, so I'm going to get 13 and 8. One of those numbers has to be negative. So if I go 13b and add negative 8b, then I'm going to get 5b. And that's exactly what the middle term is. So it turns out that those are the right factors. So that means I get b plus 13 and b minus 8 equal to 0. Now some of you that didn't have Algebra 1 with me might not be familiar with this factoring technique, but go ahead and factor in whichever way you know how, or you can ask a former student of mine and they can happily share that method, or you can ask me and I will be happy to share how that factoring happens. All right, so now we're going to separate each one. So either b plus 13 equals 0 or b minus 8 equals 0. And in the case of b plus 13 equals 0, your b value will be negative 13. And in the case of the b minus 8, your b value will be positive 8. And of course, that's the one we want to go with because we don't want negative 13 because that would be a negative base. And then if it was a negative base, it wouldn't exist and so on and so forth. So in this case, we stick with the b value of 8. And they want us to find the base and the height. So the base is 8, but the height would be 8 plus 5, or 13 feet. This wasn't feet. No, sorry, this is not feet. This is actually, sorry about that, centimeters. 13 centimeters for the height, and 8 centimeters for the base. Beautiful. All right, so now we're going to let you do these do-it-yourself questions. It's one question with 3 parts actually. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.